It is given that for a black body at a temperature of 727 degrees Celsius, its radiating power is 60 watts and temperature of surrounding is 227 degrees Celsius. If the temperature of black body is changed to 1227 degree Celsius, then its radiating power will be. So in this question they are exactly not mentioned whether we need to find out the value of energy radiated by the object or the net amount of energy radiated by the object. As in question they mentioned the temperature of surrounding, we are going to find out the value of net energy radiated by the object. That means the amount of energy emitted minus the amount of energy absorbed by the object. So we are going to find out the value of dq divided by dt net. So we can write the equation for that is E sigma A, temperature of object raised to 4 minus temperature of surrounding raised to 4. Now it is given that for a black body at a temperature of 727 degrees Celsius, so temperature in the first situation is given as 727 and the temperature is given in degree Celsius scale. So we need to convert it into Kelvin scale. So we can add 273. So we'll get the answer as nothing but 1000 Kelvin. Radiating power is, so we can take it as power in the first situation, which is equal to nothing but 60 watt, and temperature of surrounding, that is also given in degree Celsius scale, that is 227. So we can add 273. So I'll get the value in Kelvin scale, which is equal to 500 Kelvin. Now if the temperature of black body is changed to 1227, so you can write temperature in second situation is 1227 plus 273. Again we need to convert into Kelvin scale. So I'll get the answer as something about 1500 Kelvin. Then its radiating power will be. So Rm is to compare the radiating power in first situation and second situation. So we can say that as this power is directly proportional to the value of temperature of object raised to 4 minus temperature of surrounding raised to 4. We can write the power in second situation by power in first situation is equal to temperature in first situation, temperature in second situation raised to 4 minus temperature of surrounding raised to 4 divided by temperature in first situation raised to 4 minus temperature of surrounding raised to 4. Now we can just substitute the values. T2 is given as something but 1500 raised to 4 minus temperature of surrounding is given as 500, so we can write 500 raised to 4 divided by temperature in initial situation is nothing but 1000, so it is 1000 raised to 4 minus temperature in of surrounding, which we can take as 500 raised to 4. Now this 1500 can be written as nothing but 500 into 3 raised to 4 minus, over here you can take it as 500 raised to 4 divided by 1000 can be written as nothing but 500 into 2 raised to 4 minus, this is 500 raised to 4. Now from here you can take this 500 raised to 4 as common. If you are taking 500 raised to 4 as common, so remaining thing over here is 3 raised to 4 minus 1 raised to 4 or 1 divided by, from denominator also we can take 500 raised to 4 as common. So remaining thing is 2 raised to 4 minus 1 raised to 4, which is 1. So this 500 raised to 4 and this 500 raised to 4 over here is going to get cancelled. So 3 raised to 4, which we can take it as something but 81 minus 1 divided by 2 raised to 4, which is 16 minus 1. So we can write 81 minus 1, which is 80 divided by 16 minus 1, that is 15, is the value of P2 divided by P1. And in question, the value of P1 is also given. P1 is given as 60, so we can write 60 into 80 divided by 15. So we can cancel this 16 by 15, which is nothing but 4. So we can write this as equal to nothing but 320.